Example 3 for the law of cosines. Once again, we note that we have the side angle side scenario. In this problem, we're looking for little w. The only thing I'm interested in is finding the length of little w. To do that, well, let me start with figuring out what the possible values are for this side. Remember the existence postulate for a triangle. We can subtract these two sides. 17 minus 12 is 5. And then when I add the two sides, 12 plus 17 is 29. This third side has to fall somewhere between 5 and 29. To figure this missing side, I'll use the law of cosines, which says little w squared is equal to the square of the sum for the other two sides. So 12 squared, the sum of squares, the sum of the squares of the other two sides. 17 squared minus 2 times 12 times 17 times cosine that in-between angle, the angle that's in between the two known sides. We'll call it 114 degrees. And now I'll simply plug that straight into the calculator. After you see a couple of these, you realize it really isn't that bad. The hardest part is understanding that formula. That's why I did that video on knowing the structure of the formula. So when I look at this, I'm simply going to go 12 squared, help if I could type, plus 17 squared minus 2 times 17 times 12 cosine of 114. I'm getting this answer of 598 and change. So w squared is 598 and change. I want to root that, so I have w, not w squared. So I'll do the square root of that answer. And I'm getting 24. W is equal to 24 point, we'll go 2 decimal places, 47. Now having that at 24.47, that is falling between these two values here, which I said this had have to be. That range of values was 5 to 29. 24.47 falls in there, so I think I have the correct value. And so W equals 24.47. If you don't get a value that falls in that range, you did something wrong. You probably typed something in incorrectly. So retype it in. For this example, I'm going to go ahead and find these missing angles as well. Once I know this side, I can revert back to law of sines. And so let's say I want to find this angle right here. We'll call this X. So we'll call it X. This would be big W, and we'll call this big tiger. So in order to find angle X, I can say the sine of angle X, remember the law of sines, the law of sines says it's just a ratio of the sine of the angle to the side. So I got sine of X is to 12. Now I have to use the ones I now know. So I would say sine of the 114 degrees is to, and this value that I now have, the 24.47. Now I did something similar to this on the introductory video. What I want to make sure I'm being clear about, when you are solving this, please make sure you're leaving all of those decimals in there. So I'm just bringing that 12 up in this ratio, leaving the sign by itself. So it's 12 times the sine of 114 over 24.47 and change. You want to use everything that was in that calculator. So I go to my calculator here, and I'm going to say 12 times sine of 114 divided by that 24 and change number. So I hit that, hit enter, and then it tells me that the sine of x is equal to 0.4479 and change. To get rid of the sine, I'm going to use my arc sine, because I want the angle. I don't want all of this sine in there. Of course, what you do to one side of the equation, you do to the other. So this leaves me with an x equaling, and I simply go to my calculator with all of that decimal. It's so important to keep that decimal every time. I go second sine, use all of that decimal, and now I have a very precise answer. 26.61 degrees. 26.61 degrees. 26.61 degrees. I can come up here, call this 26.61, and then to find that missing angle, well, I know there's 180 degrees in a triangle, so I can add these two up and subtract it from 180. So I'll go 180 minus 114 minus 26.61, and it tells me that this other angle is 39.39 degrees. You don't always have to find every little piece of information for the triangle. In fact, many of the application problems, they just want the one item. They might just want W. Okay? So if you're finding just that one piece of information, you may just go through the law of cosines and you're done. Or maybe they want an angle, and if they want that angle, then you would have to use the law of cosines so you could set up that ratio, which would be fine as well. That'd be a situation where you just run through this and you might be done after you've done the law of cosines and you just apply the law of sines one time. Really not that difficult to find all the information from the triangle. So this is your third example for the law of cosines.